All right, so we're on to matrices, and this question 5 was 42%. Got it correct. So Liam cycles, runs, swims, and walks for exercise several times a month. Each time he cycles, Liam covers a distance of c kilometres and blah, blah, blah for all the rest. And here is a table showing what's happening. So in the month 1, what that's saying is he goes for 5 rides on his bike cycle, right? And every time he rides, it's actually the same distance. I think this was the problem in the question. People didn't understand that because that's probably not what would happen in real life. And that's where I believe it was thrown a bit. But they do say up the start that every ride is going to be, because they say it's c kilometres. And so every run, he runs the same distance, and every swim he does. So when they say the matrix that contains the time, each distance, and for each of the things, it's like a transition or a multiplication matrix. So what you can do, if you set up a matrix of this run cycle, so say 5, 7, 6, 8, and 8, I'm just doing one like that. So 7, 8, 7, 6, 8, 8, 5, and 5. What happens if you times it by the one that they said, so say C, R, S, W. So C is like the distance you ride. So if you look and you do the run dive, so if you went run and then dive, if you're timesing them together, the answer will be, it'd be the total distance, because you'll go 5 times the distance that you ride, then set plus 7 times the distance you've run. And can you see how that then gives the total for that month? Yeah? So really that's how you'd work that out, or that would be that one. So then if you did run and dive, so if you went run and dive, that would give this answer here, which is 172, 165, and 162. Okay. Now, so if I just label these matrices up the top, so say I call this one, I'm just going to call it matrix A, and then it's times by this matrix, which I don't know, so I'm going to call it X, and this one I'll call it E because I know it. Now, if you look, so we know this one, we've got numbers for that one and that one. This is the question. So can you see you actually got like a little algebra expression there, and if you were trying to get X by itself, wouldn't it be E divided by A? Yeah? So how do we divide in matrices? Don't we times by the inverse? Remember that? That's how you can divide. So we're going to times E by the inverse of A. Now, because it's at the front, it needs to be at the front when you're working it out. So the way I work out this X matrix is I'm going to do the inverse of A times that E1. So you type those two into your calculator, these two like that, from up there, and you'll end up with the answer is B. Okay, so with this one, the question, you can see it's, a study of antelope population in a wildlife move regularly between 3 locations, east, north, and west. And they're saying let AN be the state matrix with the number of population of antelope at each of the spots. And when the expected population of the antelope in each location can be determined by this rule. So we have this rule here. Now, if you notice, see how it has one of those adding or subtracting extra matrixy bit? So remember, when you have them, you can't use the transition power trick. You've always got to go step by step. If you remember in our matrices sack, we had these. This was, remember those last questions? And I said you're going to have to go step by step. So that's, and they call it a recurrence. That just means that n+1. We know how, it's a rule to show you how you get the next one using the one before. So they've obviously given us all the transition and they've given you D. And if you look, they've given you A3. And in the end, the question is you've got to find west, but in A2. So A2 is the question. So what you're going to do is you've got to link everything that you've got somehow with that formula. So if I've got been given A3, the way A3 would have been found using that formula would have been T times the one before, which was A2, minus D. Okay, now if we go back to everything we've been given in the question, we have this one, we have this one, we have this one, and that's the question. Okay, if I wrote this out like an algebraic expression, just to pretend, so say I had 4 equals 8x plus 2. Okay, say that was your equation. What would you move first to solve that? Say you're trying to, up here, you're trying to solve x. What would you move first? Good. So you would bring this 2 over an equal sign, which would become what? 4 plus 2, wouldn't it? Yeah? That's essentially what you're doing, and you'd be left with 8x. So that's what you're going to do here with this matrix first. So you're solving it. I'm going to have A3, and I'm going to have, what's the opposite to minus? Sorry, that would have been minus, wouldn't it? Sorry, minus 2. So this one would be plus though, wouldn't it? Yeah, because it's a minus. So plus D, I'm going to do that, and then I'd be left with the transition times the A2. Okay, so I've done that first step. So we'll just put that in brackets because that would have to be done first. Now looking up here, so you would have done the 4 minus 2. Now, how do you get rid of that 8? You bring it over, and what would you do? Wouldn't it be? It would be divide by, wouldn't it? That would be your next step, and you'd find it. So we've got to move this transition, because that's the one we know, over, and we're sort of going to divide. But how do you divide in matrices? You use the inverse, don't you? Yeah? Now, where am I going to put this t to the power of 1? At the front of this other 2 or after it? You see how this is at the front of this A1, this one? So that means when I pop it into the solving, I'll have it at the front, and it'll be the inverse times the A3 plus D. So you can type that all out in your calculator like that. Just make sure those brackets are there, because it has to add that D first. And then that would tell you what A2 is. So if you're essentially typing this bit into your calculator using the actual matrices, you're going to end up with an answer of, let's just put the answer there. So A2 will end up being 1630, 2800 and 2270. So that's A2. So the way they had it, they had east, north, west, and the question was just for west. Yeah, so west here. So we get the answer 277. Okay, so a public library organised 500 members into 5 categories according to the number of books they borrow each month. So there's your 5 categories. Here's a transition matrix below. So if it's a transition matrix, what happens? They should add up to 1, just to remember that. So, and here's a transition. Now it's asking me in the long term. So how do we find the long term? Remember, we do the transition to a high power. So I'm going to do 50, yeah, times. Now it can be any state matrix. Sometimes we use SO, sometimes we use, it doesn't matter if you use S3 or whatever. Now we don't have a state matrix, but we do know the total was 500. So it doesn't matter how you put the 500 amongst all those 5 categories, as long as this one adds up to 500. So I might put 100 in each category, okay? It doesn't matter with the long term, you will get to the same thing. So even if I had that, even if I decided to put 500 in one of them and 0, 0, 0, 0, you will still get the same long term. Do you understand? So all you had to know is that there had to be 500 amongst them, okay? So when you do that, you'll end up with, you'll notice in the long term you get this, so 49, 96, 124, 151, and I think it's 80. Okay, and it just said which one it has approximately 96. So this was JK, so it looks like K has it. So the answer is B for K. I don't know why this was such poorly done. I'm a bit baffled, but I think you got to know to put 500 members in. Doesn't matter, I'm not sure. Okay, so we're now into the geometry and trig one. So with this one, the city of Karachi in Pakistan has a latitude of 25 degrees north and a longitude of 67 degrees east. So we've got the latitude and that of Karachi. And assume the Earth's radius is that. They're always going to give you that. And the shortest distance between Karachi and the North Pole in kilometers. So they said along the surface of the Earth. So if you feel like if you had the Earth here, and what's going to be the shortest distance? You've got, say, the North Pole up here, and wherever Karachi is on a, whatever it is, it's on a 67 longitude, you know, say it is east, so it's over here. The shortest distance is going to be along that same longitude. So remember, whenever you have these questions, some of the data has to be the same. You know, one of the geometry points. So you might not have known that the North Pole is a 90 degrees north latitude, and this one, it'll be, the North Pole's on every longitude. So whatever one the Karachi's on, we're going to say we're using that one. So it's on 67 east, all right, because it goes to the top. Just so you know, what would the South Pole be in terms of its latitude? It'll be 90 degrees south, yeah? Just so you remember that. So here you've got, in your notes, you have a formula, those world pictures, remember that? And there's one, and there's the rule, and it'll say if they're on the same longitude. So we're saying, yes, they're the same longitude. And if you look up that, you'll see the formula is, you do the radius of the Earth times pi times the angle difference between them. So we actually have 90 minus 25 over 180. So what would that be? That would be 65. Yeah. So that's how you would have worked it out. So you look over here and there's C is the answer to that. Okay. So that little world pictures, you need to have them because you're either on the same longitude or latitude. Yeah. So that's where I think the North Pole data, that it's 90 degrees north, might not have been known by the students, and that's why this one was poorly done. Okay, so with these two questions, we did these ones in our class lessons, and we've just done trig recently, so I'm not going to go through them because you can find a video on it if you go back into our trig lessons, but I'll just let you know what they were, the poorly done, but we've done these. So it's E was the answer, and 20 minutes later was the answer for that one. Just remember, what do we have to remember? The further east you are, yeah, you get the sun first. So whatever, St. Petersburg had the sunrise first, yeah, because it's more east. Okay, so that means whatever time after if you're before that, yeah. So they'll get the sun later. Okay, so we did that one. But this one I'm going to do with you guys Another poorly worded one. All right. So we've got this cone and they've given us the radius. So we have radius there. And it says the slant is x. So we've got x. And the volume of the cone is 36 centimetres cubed. Now, they're saying that in the question, the surface area formula for the cone is we can use this. And then that's what the question is. If you have a look, we have, obviously we've got pi. We have pi and we have the radius, but we don't have x. So we need to go find x. Now, if you have a look up here, can you see how, I could use a right angle triangle here and get x, yeah? So I'm drawing out, I've actually got a right angle triangle here, so this is 2.5 and that's x. If I knew this one here, I could use like Pythag, couldn't I, to find it? So can you see this is the height of the cone? Now, all right, so I could use that. Somehow I need that. Now, they're not going to give you this volume for no reason, probably, okay? Now, if you go and find the volume of a cone is given by 1/3 pi r squared times h, yeah? So if you look here, we've got volume, we've got pi, we've obviously got, and we've got r squared. We just don't know h. So can you see I've got a way now to find h? So just use the solve and we'll write 36 equals 1/3 times pi times 2.5 squared times h, comma h, and you end up with h equaling 5.5. So now I can put h, here into this one, okay? And I would have, so it's now 5.5. So I can solve for x. I can, because it's Pythagoras, I'll go solve x squared equals 5.5 squared plus 2.5 squared, comma x. And I end up with x equals 6.04. So now I have that. I can go put it into here. Now, this is the 8th question in your trig thing, so it's one of the last ones. It's going to be hard. See how we had to sort of do 3 things there, didn't we? So that's not uncommon. So you'd expect something. It shouldn't, know that you should be doing a few things in this. So if you do that, we end up with a surface area of about 67. So D is the answer.